everyone. Welcome to today's webinar. I'm Lissa Nelson with AEC, and our presenter today is Mel Mitchell with MI Metals. He's going to be telling us today about LockOut TagOut. Please note that all your computer audio and telephone lines are muted. So if you have questions during the webinar or directly after, please type your questions into your Q&A field in your toolbar, and I'll present them to Mel. If we run out of time, you can always reach out to Mel directly or contact me, and I will see that Mel gets your questions or gets back in touch with you. Mel Mitchell is a veteran of the U.S. Air Force, where he spent 20 years working in various careers, primarily in civil engineering, and later in his Air Force career, he worked in the environmental, health, and safety field exclusively. Mel retired from the Air Force as the non-commissioned officer in charge of wing safety for Maxwell Air Force Base in the year 2000. Since then, Mel has worked in the aluminum extrusion industry, and since 2004 has been working for MI Metals, except for a 3-year period where he worked for Mountain Ridge Metals. Mel is currently working as the Environmental Health and Safety Director for MI Metals, and also works extensively with AEC, and is a member of the Standards Committee also. He's also with the Webinars Committee and is current chairman of the Safety Subcommittee, where he has also been the AEC liaison to the ANSI B11 Standard Development Committee, which is the entity that writes machine guarding standards for ANSI since 2004, and he is the current chairman of the ANSI B11 17 Rewrite Subcommittee, which is working on the newly updated standard for guarding of extrusion press systems. Mel is totally and completely committed to safety. We truly appreciate him and his sharing nature and teaching us all about safety. So with that, I am pleased to turn over the webinar to Mel.
Thank you, Liz, and welcome everybody, and good afternoon wherever you're at. I guess if you're out on the West Coast, it's still a little bit of morning left, but I hope you're having a good day wherever you are. I'm going to talk today about LockOut TagOut, and we've done LockOut TagOut several times in webinars, and I'm going to try to put a little bit different stroke to it today. So bear with me, and we'll see how this goes. I think it's pretty good information. As I was doing this presentation and putting it together, I was doing a bunch of research, and I know quite a bit about LockOut TagOut, but you never learn everything. So, just let's take a look, and we'll see if anybody gets any new information today. And I've got to make sure my slides are working. There we go. So why do we do LockOut TagOut? Well, the big reason is right here. OSHA says we have to. 1910-147 is consistently at the top of the 10 most cited regulations every single year that OSHA has. It averages 2,000 or right around 2,000 and sometimes even more citations per year. But before we go on, let's get a little basic understanding. And this is something that people sometimes struggle with. So I wanted to discuss this just real quickly. There are 3 basic terms that everybody needs to know: LockOut, TagOut, and LockOut TagOut. Okay? LockOut is the act of isolating an energy source and applying a lock so no one can turn it back on again. Okay? TagOut is the act of tagging out an energy source. Yes, OSHA says you can just hang a tag on it and hope nobody is dumb enough to come along and take that tag off. All right. The reason they have this is for some archaic machines that simply cannot accept a lock. There's no way to put a lock on it. Now, personally, at our plants, I don't know of a single instance where you can't apply a lock, but they make that allowance. LockOut TagOut, on the other hand, is applying a lock and then putting a tag on your lock that says that who the person is that applied that lock. So if you do that and And that way it has to be identified, and that's the way to do it with LockOut TagOut. And one thing I will say about the LockOut TagOut, when you're making up those tags, a standard tag is fine. It has to say words like danger, do not operate, do not turn on, whatever, and have the name of the person. I personally, if you can do it, highly recommend that you put the person's picture on that tag. I mean, not everybody knows everybody in the plant. I know most of our plants are pretty small and it may seem like it, but you might have somebody out there and they see a person's name and they don't know who that person is, but they see the person's picture with their name and they say, oh yeah, I saw that guy right over there. He's working on that. And if they know and can look at it and say, if I turn this switch on, that's who I'm going to kill. All right. I had an experience with TagOut, and I'll just kind of share that back years ago. I believe I was working at Malmstrom Air Force Base, so this was pre-1988. And I was working on the roof of a dormitory changing out a motor. And the circuit breakers, we didn't even know what LockOut TagOut was at the time. I just turned the circuit breaker off and put a piece of tape over it and said, don't turn it on. And I was up working on this motor, and as I was kneeling down connecting the wires, all of a sudden the wires arced and melted the conduit right back down to the level of the roof. And I went back downstairs to the circuit breaker and turned it back off. And a few minutes later, here comes this guy coming out of the room and complaining that I had just shut off his music. Well, needless to say, we had a very intense conversation. And I outranked him, so I made him stand there and watch that switch for the rest of the time that I had to go back up there and fix the conduit and put the wires back in and rewire that outlet or that motor. But it's not a really good way to do things. I mean, tags are easy to get around. And the last thing we want to do with LockOut TagOut is make it easy to get around. So anyway, that's enough about that little bit of basic understanding. Let's go right on into some statistics. And I don't usually use a lot of statistics, but these were pretty interesting. And I used 2019 because I had these statistics available pretty easily, so that's what I'm using. You just figure it's about the same every year. The most cited part of 1910-147 is the part about training and communication. They had 572 violations of this in 2019. And you can read right there what it says about training. The employer shall, so it doesn't say might, shall provide training to ensure that the purpose and function of the energy control program are understood. Now, OSHA uses that word a lot, understood by the employees, that the knowledge and skills required for the safe application, usage, and removal of the energy controls it's required by these employees. And then they give you three types of employees: authorized, affected, and other employees. Personally, I think they need to do away with the other employee thing because it's basically the same as affected employees. But the authorized employees are the really important ones, where they have to get their training that tells them what kind of energy sources that they're going to have, the type and magnitude of energy available, and the methods and means necessary for energy isolation. Affected employees, you have to give them the basics, but you're basically just telling affected and other employees, look, if this is what a LockOut tag looks like, this is why we put it on the machine. Don't touch the thing, because if you touch it when you see that and you get it turned on, it could kill somebody, right? I mean, it's really pretty simple what we have to train affected employees, but authorized employees are the ones that have to have a lot of training. Okay, so the next thing is the second most violated is 500 violations for periodic inspections. This one does not surprise me, right? The employer, that's us, shall conduct periodic inspection of the energy control procedure at least annually. This is exactly what OSHA says, to ensure that the procedure and requirements of the standard are being followed. I have seen OSHA guys in the same office sitting right desk to desk with each other, arguing about what this means, right? Interpretation is the key to compliance in this. And just so you have an idea, I have had OSHA guys tell me so many different things about this. I've had them say, oh, this means, I had one guy standing in a Windows manufacturing plant where you've got 250 to 300 different machines. And the OSHA guy tells me you have to take every single machine-specific procedure to the machine every year and audit it and make sure that it's still applicable to that machine. And I'm like, you got to be kidding me. I got 300 machines here. You think we're going to do that for every single machine? And we had a kind of a discussion. And he said, well, maybe if you only did 50%, and if the machines are kind of the same, then maybe you don't need to do all those. And I've had an OSHA guy say, oh, this just means you have to check your written program once a year and sign off that it's still applicable. I've had people say, no, this is where you have to have someone go out and do a lockout tagout, and you audit them while they're doing the lockout tagout to make sure that they're performing it correctly and the machine-specific procedure worked. And these are OSHA people that don't know what it means. So our approach is we have a written program, and we audit that program once a year, someone who is familiar with it, and they sign off on the front page and put the date that they audited on it. We audit all of our training records every year and make sure that all of our people are trained the way that they're supposed to. We do a desk audit of machine-specific procedures, a percentage of them, and make sure that they're covering the things that they need to do. And then periodically, 2 to 4 times a year, while somebody is doing a lockout tagout procedure, like a maintenance guy will be told, hey, you guys need to go over there and change the butt shear on the press. And well, if they're going to change the shear blade, that butt shear blade, they're going to have to get into the press, so they're going to have to lock and tag it out. So somebody else that is familiar with the lockout tagout procedure goes out with a checklist and watches them while they lock it out and just make sure that they know what they're doing and they follow the proper procedures and that the machine specific procedure actually does work the way that it's supposed to do. And I'll show you some more stuff about that as we get a little bit further into this webinar. The next one is energy control program. This is not having a basic program and 300 violations. I don't know. I mean, maybe I've been in the industry too long and in safety, but I can't imagine a business that has people getting into areas that they could get crushed in or electrocuted or whatever, not having an energy control program, right? So it tells you right here, the employer shall establish a program consisting of energy control procedures, employee training, periodic inspections, and ensure that before an employee performs any servancy or maintenance on the machine or equipment, that person will be trained and that they've released all the energy, and the machine and equipment shall be isolated from the energy source and rendered inoperative. Now, one thing that I will say here, they're talking about the entire program, which consists of the written program and the machine-specific procedures. When you do machine-specific procedures that the authorized employee is going to do, I recommend a very graphical format. Yeah, you can be legal and just have a procedure that says, okay, go to the northwest corner of the plant and turn off the valve you find there, and go to this switch panel and turn off this number switch. That's legal. I mean, to have just that simple and no pictures and no colors and no nothing. But I have found that people pay attention when they see colors and when they see photos. So when we do lockout tagout machine specific procedures, use colors. Use like red for electric and blue for gas or for water, and yellow for gas maybe. And I'll show you an example here in a little bit. You'll understand what I'm talking about. But anyway, 300 violations for no energy control program. All right, and then the application of controls is 185 violations. So this is talking about machine-specific procedures. It's a lot like the last one, and it says that the controls shall do these 5 things. And preparation for shutdown machine or equipment, actually shutting it down, lock or tag out devices applied to all the points, verify, so you test your machine, and then when you're all done working, release from LockOut TagOut. Now remember, these things, OSHA is just the minimum. I recommend going a lot further, and I'll show you a few different pictures. I mean, if you go online and type in and just Google LockOut TagOut, you'll find all different kinds of graphic representations, from the very simple notify, shut down, isolate, attach, verify, right? And with little things in it. So a little bit more complex with 10 items: identify, notify, turn off, locate, isolate, lockout, test, return, perform required tasks, and then remove your devices, all the way up to the sticker shock, right? 12 steps. And if you look at this, it talks about ask for a lockout tagout permit. Now, personally, I can't see any, I don't know of anything in an extrusion plant that might require you to go as far as having a permit. But, you know, there are some rules and some people talking about possibly starting to require them. I don't see it happening in the next 10 to 15 years, so don't get excited, right? But what I would say, if somebody was to have a permit, to need a permit for lockout tagout, I would say something like, you know, just picture a car manufacturing plant where you have a conveyor building cars that's 2 miles long. And when you start to lock out and tag out a section of that, you're going to affect a lot of different operations. In that case, they may want to require somebody to get a permit before they start working on it. But the rest of this is actually pretty good. Inform all related personnel, isolate the energy, test whether it works. I would put your lock on before you test it, but it's got that in there. And then start your work. And then after you complete your work, clean your area up. I mean, how many times do you see where someone goes in and works on something and you walk back by and there's several nuts and bolts or parts laying around, right? Check that the work is done, remove your lock and tag, turn the machine on, and then make sure that it runs correctly. I mean, really, these are things that everyone should be doing when they do a lockout tagout, when they're finished up, when they start, and it goes through the entire process. So, you know, I thought it was pretty interesting, but when you first look at it, you say, wow, that's a lot of crap. Hey, it's not really all that much. It's what you should be doing. All right. So why do we do lockout tagout? OSHA says that we have to. Just to put some numbers on it, just the violations that we covered, 1,557, if they were serious violations. OSHA now fines, as of January of 2022, $14,502 per serious violation. So if they had this many violations, that's $22,579,614. And if they were considered willful or repeat or failure to abate, those are $145,000 a piece. So there were probably a few of those in there where they proved, hey, this guy knew what he was supposed to have and he didn't have it. That's a willful violation. That's $145,000, right? But you look at that, $22,579,614. It's only money. When I'm teaching people, at least in our facilities, and I start teaching about emergency procedures and if something catches fire, and the first thing that I tell everybody is there is absolutely nothing in any of our plants that is worth one single human life. All right. I tell them we can replace the plant. We got insurance. I mean, yeah, I don't want to have to do it. I don't want to have to go through all that stuff, but nothing is worth somebody dying over, right? And lockout tagout can kill people quicker than anything in your facility, right? It's important. While it's important, failure to comply simply means fines. And like I said, that's only money. Lockout tagout accidents, I have done a lot of them, right? I have looked at them. I've come in after the fact. I've gone to other companies and helped them after they've had a lockout tagout incident. I mean, just a few is. I saw one guy. He took a cover off the back of a finish saw on a press, and he put his hand in there, and he turned a bolt, and he hadn't blocked out the gravity of the saw coming down. And the saw came down and caught his hand. Luckily, his hand wasn't in a really bad pitch point. It just caught him. And they had to cut a hole in the side of the saw, in the side of the box, while he was trapped, and jack the saw up out of the way so that he could get his hand out. One of the worst injuries that I've seen in recent years was I saw a guy get his arm caught in an optimizer. And what he did was he took the guard off and tried to clean a roller on an in-running nip point, and it caught his arm and drug him in up to his shoulder. The plant manager in that instance had to stand there and hold him while for almost an hour while they broke the machine apart so they could get his arm out of that machine. And he wound up losing his arm from just below his shoulder. He only had about 3 inches below his shoulder that was left, right? I've seen people thrown out of pits, thrown around. One guy that I know of was down in a pit with a loader arm, and he asked somebody to push a button, and the guy pushed a button, and the loader arm activated and threw him out of the pit. Luckily, he wasn't killed. He was just bruised up, banged up ribs, all that kind of stuff. And one of the fatalities that I didn't get involved with, but in an extrusion plant a few years ago, there was a fatality where an individual was caught between an armature on a saw and a wall and was basically crushed, and that person actually died. And personally, I don't ever want to have to do a fatality investigation because you've never done anything harder than going and talking to a wife and kids or another spouse and why the person's not going to be coming home again, right? So why do we do lockout tagout? Well, because it's the right thing to do. And we should be going above and beyond anything that OSHA requires, right? Okay, what should we really do? Well, let's look at the basics. OSHA, right, 1910.147, just the minimum. It was established in 1990. That's when OSHA first came out with this rule, 1990. Then there haven't been any changes since 1990. OSHA tried to change it a couple of years ago, but they were trying to change it in a bad way so you couldn't use alternative methods, right? So the OSHA standard has really become dated, especially with all of the new technology that we have and the way that things work today. There's a lot of their standards. 1910.147 is just one of them that's really become dated. And they have a really hard time making changes because there's so many special interests that try to get involved, and they try to make changes that once they may go by what some group tells them, and then find out, well, we can't do that in industry. And so they have to back off, and it just takes them years and years and decades to actually make change. Luckily, there is an alternative, and this is what I really wanted to get into. It's much more comprehensive than OSHA, and if you've heard me talk, you know that I like the ANSI rules. ISO has some good ones, but ANSI is usually pretty darn good, right? So let's take a look at ANSI. ANSI ASSP Z244.1. This rule was updated in 2016, and it was reaffirmed by the group in 2020. Instead of basic guidance, it gives you actual comprehensive guide. It provides recommendations and examples of how to do risk assessment, how to build the basic program. It talks about training, alternative methods, and a ton more. Most important, it's not 30 years out of date. So let's take a look at ANSI Z244.1. Now bear with me because I'm actually going to bring the ANSI rule up, and it requires me, if they have got it locked up, so I couldn't put notes in it. So I'm going to have to scroll back and forth to get to the spots that I wanted to discuss. But this is the actual rule, okay? And anyone can go online and buy this, and I'll put the web address up on the screen here in a little bit. But there's just a few things that I kind of wanted to point out that this rule has. I mean, first of all, the OSHA rule is just a few pages, 1910.147. If you look at this one, it's 128 pages. A lot of it does not apply to everybody, but it's there to help if you need assistance, and it gives very good guidance about how to do different things, right? So if you look at it, it goes through scope, purpose, definitions, the whole 9 yards. Talks about responsibilities, and it talks about suppliers, users, and personnel. Now, everybody says, well, okay, I'm an aluminum extruder, I'm a user. Well, maybe not. When you start reading about what this thing talks about as far as users, if you have something and you modify it, then some of the supplier rules might apply to you too. But it goes into depth and explains those. It talks about designing machinery and equipment specifically so that it can be controlled and so that it can be locked out. I mean, I can't tell you how many times as a maintenance guy, when I was in the Air Force, I would go into something and start looking at it, and you look at it and you say, what idiot designed this? It was some engineer or several engineers sitting around that designed this machine, and they didn't even think about what has to be done to it for maintenance. And we would have to go through all kinds of hoops and things. It talks about energy isolation devices in the design, control restraints. I mean, you can read it. I'm not going to sit here and read the whole thing. Then it talks about the actual energy control program, okay? And it actually goes into it and talks about the user shall implement a control methodology as part of its hazardous energy control program for machinery. And it talks about what you actually have to do to have a robust energy control program. It talks about identifying operational procedures, implementation, program maintenance, and goes through all of that stuff. And then it has several of these flow charts. And the flow charts actually simplify things. So you start your process. Is there a hazard control program? Yes or no? And you can go through it, and it'll lead you through step by step what you need to do to develop the proper things to be able to put an energy control program into place. Right? Talks about communication and training. I mean, OSHA has like 2 paragraphs about training. And this talks about how to actually do it, what you should be training your authorized employees to. You should be training them on all these things right here, right? And it talks about a note down here. It says users should avoid exclusive use of generic training programs. They do not recommend, at least for authorized employees, that you just go out and buy some video from somebody and show them the video and say, okay, now you're an authorized employee. They want you to go through these steps with your authorized employees and actually show them what they're going to face when they're on your plant floor. Just because they've been in my plant doesn't mean that they know how the things are set up or how they work in your plant. I mean, when you go from, even within the same company, from one plant to the other, things sometimes change pretty dramatically, right? So they actually go through and they talk about affected employees, right? And what you should consider the level of education and the primary language when you're training them. Okay, I mean, you wouldn't want to train an engineer the same as you would train someone who never even finished grade school, right? You need to talk to them at the level that they are. Maybe that person that never even finished grade school is a better mechanic than that engineer, but you have to talk to them at the level that they're at. And you have to kind of be careful with that too, right? Then you have to assess your training. So they want you to verify the learning, verify that the person understands. So how do you do that? You either have them show you that they understand, or you do some kind of test or some kind of audit of them to make sure that they understand what you're doing. Talks about retraining, program monitoring, the whole 9 yards. So let's jump back up here to the top real quick. And there's a couple other things that I kind of wanted to show you, and it's easiest to get to them by being at the top, right? Talks about group lockout, tagout. Then it talks about alternative methods. Alternative methods confuse a lot of people, okay? An alternative method is something that you use when you need to leave energy in the machine somewhat, but you have to do it in a way that you can ensure that the people are just as safe as if they locked it out and tagged it out. Now I'm going to use a non-extrusion example here. One time I was in a plant and they got an OSHA inspection. Actually, this was a screen plant where they manufactured window screens and sliding screen doors and stuff like that. And as the OSHA inspector was walking by, there was a section of the plant that was owned by a plastics plant, a plastics company, where they had injection molding devices, where they made the little corners for the screens, right? And they were walking by, and the OSHA inspector wasn't even going to go over there. But they looked over there, and they saw a person standing up inside one of the machines. And they walked over and looked at it, and the machine was not locked out, and they were up above the level where they needed fall protection. There were several things wrong. But one of the things that they cited them for was not having the machine locked and tagged out. Now, this was one of my first really deep dives into alternative methods. In that particular machine's ANSI standard for that industry, for the plastic injection molding industry, they had specific alternative methods for being able to do certain things to that machine without locking it out. One of the things that they had in there was being able to change dies without locking the machine completely out. The reason is, and it's kind of the same for extruders, sometimes you don't want that press to completely cool down because it's going to take it all day to heat back up again. And the same thing was true with that plastic machine. They had a specific alternative method where if the door had a certain type of interlock on it, you could use a chain and a lock and lock the door in the open position so it couldn't be closed. And that was an alternative method to use while you were changing the die so that the entire machine didn't cool down and take hours and hours and hours to heat back up again. And I was able to take that alternative method out of that ANSI rule and take it to the OSHA area office and say, look, this is the alternative method that we are using there and why we're using it, and get that citation thrown out for at least the energy control. Well, they still got the citation stuck where the guy was climbing up in there and climbing over top of the machine because he was too high, but we got their lockout tagout one taken out. So that's alternative methods, and they talk about it right here. It says lockout tagout shall be used unless the user can demonstrate an alternative method will provide effective protection for persons. When lockout tagout is not used, an alternative method shall be used only after hazards have been assessed and risks documented, right? So it talks about alternative methods. And if you've never done a risk assessment, it talks about risk assessments in this thing too. Okay, so I'm going to run on through, and here's a risk assessment process diagram, right? So you prepare for and set limits of the assessment. You don't want to wind up assessing your whole plant when you're just trying to assess one section of one machine. Identify the tasks or hazards, assess initial risk, use a risk scoring system, Hierarchy of control. You want to use the hierarchy of control to reduce risks, assess residual risks. Is the residual risk acceptable? Yes or no? And it leads you through what you need to do. So I know I may be talking about some things that people are sitting there going, say, what? But believe me, if you were to read about risk assessments and how you do it, this is a good spot to start, right? So hierarchy of control. The first thing you want to do, if you can do it, is eliminate the hazard through design, then substitution, then guards or safety devices, then awareness, then procedures and training, and finally use of protective equipment. This is your standard hierarchy of controls, how you want to control risks to keep people from getting hurt, right? And they go through, this is more just hierarchy of controls and giving you examples. Like I said, this standard really does capture a lot of information, and it will walk you through how to actually do each step. Now, let's get on down here to the annexes, because if you look at ANSI standards, I find a lot of useful information in the annexes. And we were just talking about risk assessment. Annex A talks about the risk assessment process, and it will take you through step by step. And if you really wanted to take a deep dive into risk assessment, there is another B11 standard that actually goes through, that is named risk assessment for machine guarding, that will go through all kinds of things. So, you know, you can. I'm not going to sit here and go through every single bit of this, because I want to show everyone several other different things in this standard. Right, here is a sample risk assessment for alternative measures document, and it kind of gives you an idea about how you can build it if you need to do a risk assessment. Is your risk level medium, low, high, and you can use different matrix to evaluate it, whatever works best for you. Remote lockout systems. I don't know of any remote lockout systems, at least not in any of my plants, but it gives you the option here of being able to put those into place, right? Sample lockout tagout program or policy. Now, this is the one, you remember there were 300 citations for people not having this, all right? Now this ANSI Z244.1 costs $100. You can buy it at the ANSI store or on the ASSP website, and I'm going to put up a link to that here in just a little bit. And it gives you the program. You can take this program, this annex, and copy it, put it into a Word document, make very few changes, and you're covered. You have everything covered. I mean, does OSHA do that? No, OSHA says, well, we're not allowed to do that. Well, this is a consensus standard, and they are allowed to do it, and they did. So it talks about it builds you a program right here. So you can take it and use it, right? I mean, it goes through everything. It talks about, one of the things it talks about right here, release from lockout tagout. It talks about special lockout tagout situations. It goes through everything. Okay. And like I said, I know I'm scrolling through this fast, but I wasn't planning on sitting and reading the whole thing. Talks about a lockout tagout inspection form. You remember where I said when a person goes out to do lockout tagout and someone else goes out and watches them, that's what this form is. It actually will, you can put down the people's name, talks about what different types of things there are, and then goes through a yes or no checklist. And you can go through it, and you got to be careful. Some people will take and use these to beat people up. If you identify a deficiency, somebody forgets to do something, don't look at it as, oh my God, I got to fire that person when you're doing this. Take it as an opportunity and say, okay, bring everybody in, and let's have a little bit of retraining on lockout tagout for authorized employees and go over the things and make sure that everybody understands. Because if one person fouls it up, the chances are there's more than one person. That person had to learn it from somebody. So, take and go through it with them. Let them know, look, this is so we can get better, right? And there it is. The form is right here for you. All you have to do is copy it. You can even take and what I do is put it on our own letterhead, make some minor changes if there are things in here that don't apply to one of our plants, and use the thing, right? So then we talked about the one other thing that I kind of wanted to mention, and this one is something that I don't think gets done enough. Management of change, and not just for machines. Anytime there is a change, particularly a significant change in your workplace, you should be doing some type, even if it's simple. This is pretty in-depth, but even if it's simple, management of change. Someone needs to step back and look at what is changing, and at least from the safety aspect, how is that going to change the facility or the workplace, the job station, and what new risks are going to be put in, and how do we alleviate those risks before the change happens, right? So they give you a guide here to kind of walk you through management of change. And, it's really quite comprehensive. And then lockout tagout procedures. Remember, we talked about the different steps. This is machine specific. And instead of having the 5 steps that OSHA has, they have, how many steps here? That's 7 steps, which is what most companies are using now. Preparation for shutdown, equipment shutdown, isolation, application of lockout tagout, checking for stored energy, verifying, making sure that that's locked out, verifying the isolation, try to start your machine up, and then when you're done, releasing from lockout tagout, right? So it goes through a little bit more than that. Here's what I was talking about for colors. This is actually a lockout tagout procedure for an injection molder. Now, this looks like it's probably written using the Brady lockout tagout program. I'm not advertising for them. I have used it. It's a good program. If you were interested, go to the Brady website and go hunting for it. The only thing is once you build your program around it, it's got a proprietary thing for saving it. And to be able to make changes, you have to use that program to make the changes. But if you buy it, you've already got it. So, but if you look, the different colors, talks yellow is special precautions. Red down here in the actual lockout tagout is electrical. Gray is hydraulic. Blue is pneumatic. If it had water, you might use green for water. It has pictures to show where the lock goes and where you lock out and tag out the particular machine. This is pretty simple with just a few lockout tagout points, but I think that's the way it is in most extrusion plants. Most of the things that you lock out tagout are actually pretty simple. Here's another one for a different injection molder, right? Talks about temperature and allowing the thing to cool down. And they give you several other samples. This is a sample of a placard. So what they do here is they'll take, see it says you are here. And so you would be standing there, and this is the control panel or electrical panel. And they take this placard and they make it up for this turbo shaft groove grind, whatever that is. And they point out where the lockout tagout points are. And then they laminate this and stick it right on that panel. So it's easy to find, it's highly visible, and it gives everybody a good heads up. And here's a different kind of placard that talks about it, where they put it on this machine right here, and they laminate it, and it's got all the points laid out for you, how you do it. Okay, it's pretty neat. And then if you wanted to get into the lockout tagout permit, I mean, totally up to you. This is an example of a lockout tagout permit. Of course, you would have to make it up how best it fits you. And then talks about group lockouts and how to do group lockouts and different examples of big group lockout things. You know, because I mean, if you have a group of people working on something and they get into it, each person has to have their own lock and their own tag on that thing, unless you do some kind of special lockout where you have a group lock box or something of that nature. And this talks about that, and it gives you several examples on different ways that you can do it. Okay, and then finally, it goes into, and there's nothing in here. Oh, there's more group lockout tagout with pictures. Sample alternative methods, risk assessments, and then it goes into specific industries. There's nothing in here on the extrusion industry, but you never know what kind of ancillary machines you might have in your plant, and something in here might apply to you. But you know, if you buy this rule, this standard, then you've got it, right? So totally up to you. You can go by the OSHA standard. You can live within the means of that, and you can have a robust program. But if you're not sure and you want to go a little bit further, I highly recommend Z244.1. Just like forklifts, I highly recommend the ANSI forklift standard. It's so much more than OSHA. Just like machine guarding, the ANSI machine guarding standards are so much better than OSHA 1910-212. I mean, when they try to pigeonhole an extrusion press into what's required in 1910.212 or any of the other OSHA machine guarding standards, it is really hard. So that's why we're rewriting ANSI B1117 right now, right? So, you know, there are a lot of really good standards out there that ANSI has developed that really help us in doing our job and keeping people safe, okay? So we just looked at ANSI Z244.1. Why do we do lockout tagout? Well, like I said, if you don't do it, accidents, I mean, what's an arm worth? What's a hand worth? What's a life worth, right? You're paying a little bit to do it right and keep people safe, okay? So where can you get ANSI ASSP Z244.1? Every place else that you can get any ANSI rule, webstore.ansi.org. And once you're there, you search for Z244.1 2016, and they reaffirmed it in 2020. Be careful, because when you start searching, it'll pop up links to the old rules. And while I don't think they'll still let you buy the old rules, it just kind of makes it a pain. You may have to scroll a little bit to get to the one that you wanted. Okay, so wow, we actually took 50 minutes. I didn't think I was going to be able to run it out that long. So any questions, anything from anyone?
Let's see. I don't see any questions yet.
Well, everybody knows that you can always forward questions to Liz or Nancy, and they will forward them on to me and the rest of the safety subcommittee, and we have no problem, giving our opinions. So, if you have a question, by all means, forward them into us. And hey, safety is the only field where it's urged that you plagiarize. If I have anything and you ever want to use it, I don't mind you taking my name off of it and sticking your own on it. Just use it. So
you're so generous, Mel. Speaking of that, we have recorded today's webinar, and it will be posted within the next few days on the AEC website library. Yeah, that was great, Mel. Thank you so much. We will also be sending out the typical evaluation survey later today or tomorrow, so keep an eye out for that, and please participate in that because we do depend on your comments and feedback for future programming. Just a couple of announcements. On May 25th, Richard Dixon will be with us presenting on transverse weld. Boy, the year is passing quickly already. We're getting ready to go to ET next week. If you haven't registered yet, please plan on attending. It's going to be a wonderful event. This is going to be our celebration of 50 years of ET. And you can come and make a whole week of it. We have lots of activities. And of course, you can take the family to Disney. We have something for everyone during ET. On Monday, we've got paint and powder coating, process analysis, and anodizing essentials workshops. And we also have our very special Thursday night dinner celebration to recognize the 50 years of ET. And on Friday, we have the terrific die clinic and also the ET Founders Golf Tournament going on. So there's all kinds of great stuff happening next week. You can always find details on these and any other events and webinars and updates at aecmeets.org, so check that website often, and also your inbox for AEC Meets newsletters. I don't see any questions, Mel. You were very, very
well. You all have a wonderful rest of your day, and I'll see you next week at ET.
Super. Looking forward to it. Looking forward to Florida weather.
Yeah, they'll probably have a thunderstorm.
Don't say that. Okay, everyone, thank you so much for being with us today, and we will talk to you soon and hopefully see you soon. Thanks again. Bye now.
Bye.